Hi guys, in this video we are going to focus on what is set and mathematics. So set and mathematics. A set is a well-defined collection of distinct objects. So a well-defined collection of distinct objects is called set. There are two terms that you must keep in mind. The first one is well defined and the second one is distinct. Well defined means that the objects must be clearly defined and there should be no ambiguity about the objects, right? So they must be clearly defined and no ambiguity. Right? And the second one as distinct means that the objects in the set must be unique and different and there should be no repetition in the objects. So distinct means that the objects must be unique, different, and no repetition. So this is the definition of a set. Now we're going to take some examples of set. Let's suppose I have a set A which contains the elements 1, 2, 3, 4 and 5. So this is a well-defined collection of distinct objects. Here the objects, elements or the members of the set are well-defined and different means that they are distinct and they are enclosed in curly brackets and they are represented by a capital letter just like A. So this is a set. Here the objects inside the set are called elements or members of the set means that 1, 2, 3, 4 and 5 are the members of set A. So this is the set of first 5 natural numbers. So set of first 5 natural numbers. So now let me have another set B which contains the elements A, B, C and D. So this is set B which contains the elements A, B, C and D. This is the set of first 4 alphabets. So this set contains first 4 small letters, or this is the set of first 4 small letters of alphabets. Now let me have another example C which contains the elements Tom, Sarah and Peter, right? So this is also a set which contains the element as the names of the person. Now we are going to jump into some collections that are not sets. For example, let's say I have a collection A, right, which contains the elements as 1, 1, 2, 3, 4 and 5. This is a collection of objects, but there is a repetition inside the elements, right? So this is not a set. Now let me have another example of such collection. Set B, which contains the element as Tom, Sarah or Peter. Right, so if we look at these two examples, then the first one have repetition inside the elements and the second one as there is ambiguity about the objects. We have clearly defined the Tom, but there is ambiguity about the Sarah and Peter. So this is also not a set. Now let me have another example C which contains the elements is rice, cake, tea, right? let's say this is autistic for, but it might be autistic to me but not to everyone. So this is also not a set in mathematics, because so this is also not a set because this collection may be tested to me but not to any other one. Now let me have some more examples of set in mathematics. So let's suppose I have say a set of multiples of 4. So the set of multiples of 4 are, I will represent it by A, and the set of multiple of 4 are 4, 8, 12, 16, and so on, right? Here these three dots represent that the pattern of these number is continued up to unlimited numbers, right? That means that the pattern is continued but to unlimited extent. Now let I have another set B which contains the elements the first 10 multiples of 2. So 2, 4, 6, and up to 20, right? Here these three dots are called ellipses in mathematics, and it shows that the pattern of these number is repeated until 20. Here the first 10 multiple of 2 start from 2 and ends up on 20, right? So this is the set of 10 multiples of 2, and this is the set of multiples of 4, the set of natural number. So the set of natural number is represented by n, and it contains the elements which start from 1 and 2, 3, 4, 5, etc., and so on, right? That means that the pattern is continued up to unlimited number. The set of whole number is represented by W, and it contains the elements 0, 1, 2, 3, 4, and so on, right? The set of integer is represented by Z, and it contains the element as 0, positive, negative 1, positive, negative 2, positive, negative 3, positive, negative 4, and so on up to unlimited number, right? So this is the set of integers. So these are the common sets that we will use in further lessons. Now we're going to discuss the cardinality of sets. Cardinality of set. Cardinality of set. Cardinality of a set as the number of elements in a set. Suppose that I have a set A which contains the element as 1, 2, 1, 3, 5, 7, 9. You look at this set, how many elements are there in this set? So 1, 2, 3, 4, and 5, right? So the cardinality of set A is 5. So we said that the cardinality of set A as 5, or the number of elements of A are 5, right? Now let me have another example of set B, right, which contains the elements 2, 4, 6, 8, 10, 12, 14. So what is the cardinality of set B? We will count the elements inside the sets 1, 2, 3, 4, 5, 6, and 7. So the cardinality of set B is 7, or the number of elements of B are 7, right? So this is called the cardinality of set. The number of elements in a set are called the cardinality of set.